Hi. So now I want to discuss a very important concept with you, that is feature scaling. Okay. So to understand the importance of feature scaling, let's just consider a problem. So I have a data set over here which basically has just two features, that is age and salary. Okay. So I have age and salary of a person. Let's say I have just 2 points in my data set. I am just taking 2 points for simplicity's sake. My first data point is a first person which is 24 years old and his salary is 20,000 per month, okay, rupees 20,000 per month. And my second data point is a person whose age is 50 years and his salary is 25,000 per person. Now a data point comes to me, a person comes to me with his characteristics being age of 25 and salary being 24,000. Okay. Now what do you think? This person is similar to person 1 or person 2. Okay. He is similar to which one of these two people? If I ask this question to my machine, it would simply try to do some calculations. Okay. So what are the calculations it will do? Okay. So if I talk about these 2 points, 24 minus 25, there is this difference of 1, and 24,000 and 20,000, there is a difference of 4,000. So it would say that between first and this point, there is a difference of 4,000 and 1. And similarly, it will say that between second point and this point, there is a difference of 25 plus 1,000. So that is 1,025. So machine would say that according to me, the difference between this point and this point is less compared to difference between first point and the third point. So according to me, this is more similar to second point. So our machine is going to say that the person with 25 age and 24,000 per month salary is similar to 50 age and 25,000 per month salary. But if we think a little logically, this should not be true, right? He should be more similar to the person with age of 24. Yes, his salary is little different from the person with age of 24, but obviously rupees, I mean salary is a value which is generally going to be high, okay, and age is a value which is definitely going to be low. So in such a case, what has happened over here is that the value of rupees has basically overpowered the value of age, just because in natural there is a tendency that age is just going to be a number which is like going to be somewhere between 0 to 80, and rupees can be even in crores. Okay. So basically when the features are such that some of the features are naturally very high valued and some of the features are very low valued, in such cases this kind of problem occurs. So we try to do feature scaling. So what feature scaling will does is, it will simply scale this feature separately and it will scale this feature separately. So one of the example can be, let's take all these values between 0 to 1. Okay, let's take 24 as, let's say, make it 0.5 and maybe make 50 as 0.9. Okay, I mean something like this, something on this line, and similarly take this also from 0 to 1. Let's say make it 0.7 and let's make this 0.87. Something on similar on these lines, so that the effect of one feature being having a higher natural value just comes down. Okay, so just to compensate for that, we use something known as feature scaling. So feature scaling is a very important part for our problems. Okay. So why we have to do that? Just to make sure that some of the features which have naturally high values, that should not overpower my other features. Okay. Just to take another example, let's say I have a house with 5 bedrooms, okay, with 5 bedrooms and 3,000 square feet area. Similarly, I have a house with 1 bedroom and 2950 square feet. Now a house with 5 bedrooms and 2900 square feet, if I see which looks similar to each other, my machine would say that this looks similar to second one, okay, that these two look more similar rather than this one and this one. But very logically, if I talk about, again we know that bedrooms is one feature that is generally going to have a very low value, like 2, 3, 5, 1, 4, right, and square feet is generally going to have a very high value. So basically square feet is again overpowering my bedroom feature. Just to avoid this thing that one feature is overpowering the other, we have to do something known as feature scaling. Okay, like you can just consider another example in this case, like if instead of square feet I had taken kilometer square, I have taken square kilometers, what would have happened? This value would have been something like 0.0003 something like this, and then this value would have been also been 0.00, and it would have been very low, right? It would have been very low. So in this case, bedroom would have overpowered square feet. So just because changing the scale is giving priority to other feature, we should basically avoid such things. We should always try to scale them so that one feature does not get an unfair advantage over the other feature. Similarly, in a previous example, if instead of rupees I would have done in lakh, that is 0.2 lakh, okay, and this would have been like 0.25 lakh. Similarly, this would have been 0.24 lakh. Now clearly my age factor is going to overpower my money factor, okay. So age is going to overpower the factor of salary. So just to prevent these things, we do scaling. We basically feature scale all of my features, okay. So what are the ways of doing that? There are two types of scaling. One is min-max scaling and other is standard scaling, okay. First is min-max scaling and the second is standard scaling. So what is min-max scaling? So what min-max scaling actually says that choose a minimum and maximum value for your features and then scale it accordingly, okay. So just taking an example, in this example, just define a maximum and minimum values. Let's say I say that all these values should be transformed from 0 to 1 range, okay, and similarly let's transform all these values from 0 to 1, right, or I can say we can transform this from 0 to 10. Similarly, this one also will be transformed from 0 to 10. So basically we have used two ranges for minimum and maximum range, okay. So this is what we do in min-max scaling. How we actually do it? We simply do it. Let's say I have few values. Let's say I have 10, 30, 40, 70 and 100, okay. Let's say these are the values that I have which I want to scale them. So if I choose a feature range of 0 to 1, okay. So if I choose a feature range of 0 to 1, what I am going to do is I am going to feature scale in such a way that the minimum value becomes 0 and the maximum value becomes 1, okay. So the minimum value should become 0 and the maximum value should become 1. Basically this 10, that is the minimum value, should become 0 and maximum value, this should become 1. So how we do it is, from each of the values subtract the minimum value, that is subtract the minimum value, that is subtract 10 from each of them, okay, 100 minus 10, and divide each of the values by the difference of maximum and minimum values, that is 100 minus 10. So 100 minus 10 gives me 90, so divide each of them by 90. So if you divide each of them by 90, so I am going to get something like this: 0, 2 by 9, 3 by 9, 6 by 9 and 90 by 90, that is 1. So these values have been scaled to 0 to 1. So this is how we achieve min-max scaling. Here we have done from 0 to 1. What if we were told that do it from 15 to 20? 15 to 20. So how we will transform it into 15 to 20? Basically what we want is that the minimum value should become 15 and the maximum value should become 20. So basically instead of 10 becoming 0, now we want that a 10 should become 15 and a 100 should become 20, okay. So min-max scaling basically is this much, ki, if we are given a two ranges, minimum and maximum, just transform from your whole data set the minimum value to the minimum value which we are given and the maximum value from the whole data set to the maximum value that we are asked to. So if I want to transform this, first I will always take from 0 to 1, which we have already done over here. Now I am going to multiply by their difference, okay, multiply by their difference, that is by 5. If I multiply this by 5, I am going to get 0, this I am going to get 10 by 9, this is 15 by 9, 18 by 9 and this will become 5, okay, this will become 5. Then there is this last step, that just add the 15 to it, that is add minimum value to this. We are going to get this as 15 and the last one will become 20, and all these values are somewhere going to be between 15 and 20. Okay. Let me quickly go through this again. So, if our problem is that you have to transform this whole data in such a way that this 10 should become 15 and 100 should become 20, the simple way of doing it is that first take it to a scale of 0 to 1. So, how to take it to a scale of 0 to 1? Subtract 10 from this, 10 from this, 10 from this, that is minimum value from all of them, and divide by maximum minus minimum, that is now we are able to get a scale of 0 to 1. Okay. Then if this is the range that we are given 15 to 20, the difference is 5. So, multiply all the values by 5. In this way, we are getting a range of 0 to 5. Okay. Here we got the range from 0 to 1. Now, we have reached a range from 0 to 5. Simply if you will add 15 to all of them, that is add the minimum value of the range, just you will be getting from 15 to 20. Each of the values will be from 15 to 20 such that your minimum value is 15 and maximum value is 20. Okay. So, in this way we can apply min-max scaling. Okay. So, now let us discuss what is standard scaling. Okay. So, we had two types of scaling. The first was min-max scaling and the second was standard scaling. In standard scaling, what happens is that they are transformed in such a way that in each of the feature, let us say if this was my bedrooms and this was my square feet area, are transformed in such a way that the transformed values, after the values are transformed, each of the values, if I see, the sum is going to be 0, or many places you will find that the mean is going to be 0, basically one and the same thing. Okay. If the mean is 0, the sum is also 0, right. So, sum of all these values is going to be 0, and similarly sum of all these values is going to be 0 after the transformation. Sum is 0 of all the values in this particular feature, and variance is going to be 1. Okay. Sum is going to be 0 for this feature, variance is going to be 1, and same for this, sum is going to be 0 and variance is going to be 1. So, this is what standard scaling exactly is. Okay. One last thing and a very important thing that I want to discuss with you about scaling is that let us say our data set looked something like this. We had 150 square feet, okay, and we had 300 square feet over here. 150 square feet house was at a price of let us say 40 lakh, and 300 square feet was at a price of 70 lakh. Now, 2 points come to me, that is testing points. These are my training points obviously, and testing points come to me, that is 250 and 500. Okay. So, let us say I have to predict the values for this, the price values I have to predict. Now, what the case is that if I had transformed these values from this to 0.5 and 1, okay. So, if I transformed 150 to 0.5 and 300 to 1, and I have to transform this again, okay, I have to transform this again. Now, it will not happen that I will be transforming this to 0.5 and 1, okay. If I do that, if I just transform these values again, okay, if I use a new scale to transform this, then what is going to say is that for the value of 1, my answer used to be 70 lakh, for the value of 1, again it should be 70 lakh. Okay, that again my answer is going to be 70 lakh. So, this is the problem. So, what we have to do is we actually have to scale according to the training data. Okay, when we scale testing data, we have to do according to the training data. That is the scale that we used for training data. So, the bottom line is when we will try to scale our training data, we will do fit as well as transform. So, what do I mean by fit? Fit means that find the scale which you want to do, find the appropriate scale. Let us say we are doing standard scaling, find the appropriate scale, and for transform, you just transform the data as per that scale. Okay. When we are basically transforming our testing data, we will just transform it, we will not fit it, okay, because we do not want to find the new scale, we want to find the scale that we used for this. Okay. So, if 300 is 1, I want this to be more than 1. Okay, I want this to be more than 1, only then I am going to get a value of higher than 70 lakh. Let's say I am getting a value of 1.1 crores. Okay. So in this case, we always do transformation as per the training data. I mean, the scale that we use for training data, same scale should be used for testing data also. So I hope this thing is clear. Basically, just try to notice that if we have given the maximum and minimum range, let's say from 0 to 1 for my data, that is the range only for training data. Okay, that is the range only for training data. Testing data, it can go beyond 1 also, just like we are seeing in this case, that if we had 500, if this is higher than the highest point from my training data, obviously the value should be greater than 1. Okay, so this rule that 0 to 1 is only for our training to data. Okay, if I say that my features should be between 15 to 20, it is only for training data. For testing data, it can be higher also. Okay, so I hope feature scaling is clear, what is standard scaling and what is min-max scaling. It would be much clearer once we implement it. Okay, so it would be crystal clear once we implement it. So in the next session, we are going to implement it.